So in this video, we're going to look at the law of cosines. So just like the law of sines, you can use the law of cosines on any triangle. So say here's my triangle A, B, C. And again, the sides across little a, little b across from big B, little c across from big C. And what the law of cosine says, there's actually three different forms for it. So it's basically that a squared equals b squared plus c squared minus 2bc cosine of a. So the thing to notice is that the a on this side matches then with the cosine of that angle. So we could rewrite it so that you had any angle of the triangle. So you could say that b squared is equal to a squared plus c squared minus 2ac cosine of b. Or c squared is equal to a squared plus b squared minus 2ab cosine of c. And so we can use this to solve a triangle. So for example, solve the triangles. My first one here, A is going to be 98 degrees, B is going to be 47, and little c is going to be 42. So if I draw my triangle, and we'll call this angle here A, B, C. So A is 98 degrees, little b, side across from B is 47, little c, side across from C is 42, or is 42, and this side here we're calling little c. So I happen to know angle A at this point. And so I can use, since I know oops, this isn't little c, this is little a, right? Because it's across from big A. So since I know angle A, I can use that to help me find side A. So a squared equals b squared plus c squared minus 2bc cosine of A. So in this case, we don't know a squared, but we know b is 47, so 47 squared plus c is 42 squared minus 2 times 47 times 42 times the cosine of 98 degrees. And if you punch that into your calculator, a squared is going to be 4,522.4554. Now, all of these problems say to round your answer to the nearest tenth, but you don't want to round stuff, and when you're using numbers, you want to use longer than rounded to the nearest tenth. So I say go out 4 decimal places. So anytime if you're doing a middle calculation, you want to make sure you've gone out those 4 decimal places. So A is going to end up being the square root of this, 4522.4554, which would be approximately 67.2. So now what I want to do is I want to use that 67. So now I want to use that value in my next calculation. And so in this point, I want to, so I know now that this side here is roughly 67.2. And so I want to use that calculation to find one of the other angles. So if I try to find angle B, so we're going to use b squared equals a squared plus c squared minus 2ac cosine of b. So b squared, so 47 squared is going to be 67.2 squared plus 42 squared minus 2 times 67.2 times 42 times the cosine of b. And so there's a couple things to work out here. So first we have 47 squared. Whoops. So 47 squared is 2,209. And then if I did 67.2 squared plus 42 squared, that's going to be 6,279.84 minus, if I do 2 times 67.2 times 42, that's going to be 5,644.8 cosine of B. And so now, at this point, we can we want to find the cosine of B. One mistake a lot of people do is they actually do the subtraction. You cannot do this subtraction. This number here, this 5,644.8, it is attached to the cosine of B. So you cannot you can't subtract it from here because it's multiplied times the cosine of B. But what I can do is I can subtract the minus 6,279.84 from both sides. So let me move this up here a little bit. So if I do that, on the left-hand side, I'm going to have minus 4,070.84, and that's going to be equal to minus 5,644.8 cosine of B. So now we'll divide both sides by minus 5,644.8. Minus 5,644.8. So now we have that the cosine of B is equal to, so the negatives would cancel. So I have 4,070.84 divided by 5,644.8. And now to find B, I want to take the inverse cosine of that. So the inverse cosine of 4,070.84 divided by 5,644.8. And so B is going to be, if I round it here, 43.8. So now I know that B is 43.8 degrees. And to find C, all I need to do is remember that all the angles in the triangle add up to 180. So C is going to be 180 degrees minus the 98 degrees minus the 43.8 degrees. And if you work that out, you end up with 38.2 degrees. So sometimes people use the law of cosines to find one part and then they use the law of sines after that. It's not that you can't do that. It's just that you have to be careful because remember the law of sines gives us two different choices. So you still have to do more work. So even though the law of cosines is uglier, the law of cosines is actually easier because it always just gives you one answer. So we'll do one more problem here. B, A equals 49, B equals 22, and C equals 55. So again, here's my A, B, C. So little a is 49, little b is 22, little c is 55. So if we try to find angle A first, we're going to use a squared is equal to b squared plus c squared minus 2bc. I wrote it down wrong here. Minus 2bc cosine of A. So we're going to end up with 49 squared is going to be equal to 22 squared plus 55 squared minus 2 times 22 times 55 times the cosine of A. So in this case, this is 2,401 is equal to 3,509 minus 2 times 22 times 55 is 2,420 cosine of A. So if I subtract the 3,509 to the other side, we have minus 1,108 is equal to minus 2,420 cosine of A. Divide both sides by minus 2,420. And we end up with the cosine of A is equal to 0.45785. And then, so A is going to be the cosine inverse of 0.45785. So A is going to roughly be 62.8 degrees. And so again, I'm going to use the law of cosines to find B. So we're going to use b squared is equal to a squared plus c squared minus 2ac cosine of capital B. So in this case, we end up with b squared, so 22 squared is equal to a squared, so 49 squared plus 55 squared minus 2 times A, which is 49, times C, which is 55, times the cosine of B. So we have 484 is equal to 5,426 minus 5,390 cosine of B. So subtract the 5,426 from both sides. We get minus 4,942 is equal to minus 5,390 cosine of B. Divide both sides by minus 5,390. So cosine of B is going to be equal to so it's going to be equal to 4,942 divided by 5,390. So B is going to be equal to the inverse cosine of 4,942 divided by 5,390. And so I'm kind of out of room, so we'll come over here. So B is approximately equal to 23.5 degrees. So now I know that A is roughly 62.8 degrees, B is roughly 23.5 degrees, and so to find C is just going to be the 180 degrees minus 62.8 degrees minus 23.5 degrees. And so in this case, that's going to end up being 93.7 degrees. So the law of cosines looks a little uglier. It's a little bit more like algebra steps, but you don't ever have to worry about multiple cases, so it's pretty nice to use.